Dave Staublin here, and we're going to do some good math, geometry, section 5.5. It's all about properties of inequality and how they relate to triangles. So I have three sticks here, and you can see that I have a small, a medium, and a large stick. And what I'm interested in doing is adding the two smallest sticks together. And you can see that the two smaller sticks, when added together, are less than the length of the largest stick. And so the question is, can we use these to make a triangle? And I would say no, because even if you collapse this triangle so that those ends are touching, the two smaller ones are not long enough to meet at the third point. So that's no good. All right, here is my next set of sticks. You will notice that we have a small, a medium, and a large. And if we take the two smaller ones and we add them together, they are the same length as the longer one. And so the question is, can we make a triangle out of these? Well, as soon as we tilt them up into a triangle, guess what? We get a gap. And in fact, the only place we don't have a gap is when they're added together to be the same length as the long one. All right, so that's no good. All right, well, here's my next set of sticks. You will notice that I have a small, a medium, and a large stick. Now, when I add the two smaller ones together, you will see that the two smaller sticks add up larger than the largest stick. So what happens when we try to make a triangle with this? Well, it looks like now we can make a triangle. So what is the rule that we can gain from these sticks? If you have three sticks or three sides, the two smallest sides added together have to be greater than the biggest side in order to make a triangle. So let's write that down. The length of the shortest side plus the length of the medium side have to be greater than the length of the longest side in order to make a triangle. Okay, so that's part number one of today's lesson. Oh, let's do an example of this. Let's say that I have three sides or three segments, and they are 2, 4, and 8. Can I make a triangle? Well, let's check it out. What are the two shortest sides? 2 and 4. So 2 plus 4, is that greater than 8? Well, 2 and 4 is 6. 6 is not. So no triangle possible. Well, let's say we bump up each of these sides by 1. So now we have 3, 5, 8. Can we make a triangle out of these segments? Take the two shortest ones, add them together, and ask yourself, is that greater than the longest side? And in this case, 3 and 5 is 8. It's the same as 8. It's not bigger. So guess what? Can't make a triangle. No triangle. Well, what if we bump them up one more again? What if we go 4, 6, and 8? Can we make a triangle out of that? Well, there's the two shortest sides, so add those together. Do those add to a number bigger than the largest side? Yes, 4 and 6 is 10. It's bigger than 8. So, yes, we can make a triangle. Okay? Now, let's just look at this for a minute. I am curious with these. What happens? We know that 4 plus 6 is bigger than the third. What if we do 4 plus 8? Is 4 plus 8 bigger than the third side? Yes. And let's see, we did 4 plus 6, 4 plus 8. Let's do 6 plus 8. Is that bigger than the third side? Yes, it is. So here's a second piece of information, is that if you have a triangle, then the sum of any two sides is greater than the third side. Okay? Now, there is this thing called the comparison property of equality. And it sounds much worse than it actually is. But it works like this. If you have A equal to B plus C, and C is greater than 0, well, that's the hypothesis. Here's the conclusion. Then A is bigger than B. Let's do an example here. Let's say that we have 5 equals 3 plus 2. Okay, so the first question is, let's see, there's the C value. Is that bigger than 0? Yes, C equals 2, which is bigger than 0. So then, is A, which is 5, is that bigger than B? Yes, it is. So that's just a brief idea of how comparison property of equality works. Now, let me ask you a question about this part of the hypothesis. Why do you think C must be greater than 0 for this property to work? What do you think? I'll give you a hint. If C is not bigger than 0, what could C be? Well, it could be equal to 0, or it could be less than 0, like a negative number. I would like you to think about what happens if C is equal to 0, or if C is less than 0. What happens to this part of the property where A is supposed to be bigger than B? Okay. All right. Well, here's the next thing. I'm going to change pages. And what happens is I'm going to give you what's called the triangle exterior angle theorem. And it works like this. Let's say we have a triangle where one of the sides extends outwards. Well, this area is inside the triangle, and so these are called interior angles. And I'm going to label this 2 and 3. This angle right here is outside the triangle, so that is called an exterior angle. And the way this theorem works is that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1. And using the comparison property of inequality, because these angles all have to be positive numbers, we know that measure angle 1 has to be bigger than the measure of angle 2, and the measure of angle 1 has to be bigger than the measure of angle 3. So this is the theorem, and this is called a corollary. Because if you know this, then you can use the comparison property of inequality to learn more, and that's called the corollary. Okay. Now, here is the last triangle thing that I want to do with you. Let's say that we have a triangle that looks like this. And I'm going to say side A is bigger than side B, which is bigger than side C. Now, what is interesting is that if you were to measure this triangle, you would find that the angle opposite the longest side, angle 1, is the largest. And then you would find that the middle side, if you go opposite to its angle, is the middle-sized angle. And if you go to the smallest side and go opposite, then that would be the smallest angle. Pretty interesting. So let's apply that. Let's say that we have a 3, 4, 5 triangle. And we'll label these, I don't know, X, Y, and Z. So the question would be, which angle is the largest? Well, let's see, there's the biggest side, so you go to the opposite angle and measure angle X would be the biggest. And then you go to the next side, number 4, and you go opposite. So measure angle Y would be the next biggest. And then 3 is the smallest, so you go opposite, and measure angle Z is the smallest. Okay, that's it for section 5-5 in geometry. There will be an assignment, but I will post that in another location.